very excited to be here and be able to present this work that I'm going to share with you guys. Um, basically, so today's talk is going to be about putting data science products in production and at scale using cloud computing. I'm going to try and keep this talk short and open it up for questions so that we can actually talk about what are some of the problems that you can face and how you can overcome them in your day-to-day. So just a little bit of introduction. My name is Ali Murad, and my educational background is that I completed my undergrad at University of North Alabama, where I also played college tennis. So I'm a former college tennis player. And I graduated from North Alabama with a degree in computer information systems, finance with a minor in mathematics. Then I got my master's at Lipscomb University in data science. And right after school, I started working at Parallon Business Solutions, which is a subsidiary of HCA that does most of their business-related work in terms of billing, collections, so on and so forth. So basically what HCA did was they took a bunch of their business operations and they took it out of their hospitals basically and created an entity that handles a lot of those business day-to-day operations. And that's where I started after my undergrad, and I worked there for about 3.5 years. And after that, I started working on my PhD in computer science, and I'm currently a computer science PhD student at Auburn University. And I also work as a data scientist at HCA Healthcare. So I moved from that subsidiary of HCA, which is Parallon, to the corporate side, which is HCA Healthcare itself. And I work there as a data scientist in the clinical space. Okay, so before we dive into the technologies and different ways of deploying machine learning products at scale, I want to talk to you guys about what I think reality is. And that is that there's a lot of talk about doing data science. A lot of companies, they basically, it's overhyped in some ways, where everyone now wants to do machine learning and they want to do artificial intelligence. What exactly is data science? There isn't really a definition for it either. I feel like it's a very broad umbrella term and a bunch of stuff can fall underneath it. Well, what that leads to eventually is that if you're working for a large organization and they do have a bunch of money, then what they're going to try and do is they're going to try and go buy whatever they see is under the sun that does data science, and they're going to try and bring it inside the organization. Because why not? You have a ton of money, so let's give it a shot and see how it goes by buying a bunch of stuff and getting a bunch of vendors on board. Well, what does that lead to? It leads to confused employees, basically, at the end of the day, who don't really have a single framework to build products in. And that eventually leads to some really pissed off bosses and really pissed off customers, which leads back to sad employees. And the cycle repeats itself. This is the reality of how companies are doing data science right now. I wouldn't say all of them, but a lot of the companies that did not do machine learning in the past and they are new to this space, this is a cycle that majority of those companies are going through. Now, what helps? What would help is if you start with the end in mind. You think about what's your objective at the end of the day. And in most cases, you're going to realize that it's building products which deliver value to the customers. In our case, those customers are our patients. in our hospitals. Well, to be able to build products, it would be helpful if you do that with an iterative mindset. You're not going to get things right the first time. You're going to make mistakes, and you should actually make mistakes. You should be willing to fail. But you have to approach this from an iterative mindset so that you can fail, and you can fail quickly. So you have to be able to build you have to have a tech stack that allows you to quickly iterate through that product lifecycle. Because you're not going to get it right the first time. So your tech stack should be designed in a way where you're able to quickly iterate through your sprints, so that you can put something in front of the customer really quickly, get some feedback, and go back to the drawing board and iterate through it again. To be able to build something like that, to have a tech stack like that, you would need a consolidated framework. And by a consolidated framework, I mean you would be considerably better off if you know what in your tech stack does what exactly, and then not mixing those things. That will really help you narrow down exactly the technologies you need to do the tasks that you need to do to build a product. So in this talk, what we're going to cover today is infrastructure as code, data warehouses, some machine learning, structured and unstructured, and application development and deployment through containerization. And this diagram that I am presenting to you on the right, there's a reason why I've laid this diagram down this way, where your infrastructure is at the bottom, data warehouses come on top, then your machine learning, and then your applications. As we progress through this presentation, I will elaborate more on why it would help if you set things up this way. So some of the technologies that we're going to cover, Terraform, which is going to be your infrastructure as code, Google Cloud Platform, which is the cloud environment, but it could be any other cloud environment, such as AWS. Python for a machine learning framework and development, Docker for containerization, and GitHub for version control. And again, the way I have laid out these pictures on the right, there's a reason why it's presented in a way where you have Terraform, which is your infrastructure at the bottom, then your cloud environment, then your machine learning framework. You containerize that thing and version control everything through GitHub. So infrastructure as code, what is it? And what is it compared to applications themselves? IAC is exactly what it says in the name. It should be. That is infrastructure. It should not be anything more, and it should not be anything less. It is extremely important to know that infrastructure and applications are two separate things, and they should not be treated as one. Deployment and maintenance of both of these is drastically different. And we learned it the hard way at HCA. Infrastructure, you could have less frequent updates to your infrastructure, where let's say you want to update your development environment with some upgrades, or you want to deploy a new storage bucket in Google Cloud, or could be AWS, any other cloud environment. It's not very often that you're going to want to do that. But for your applications, you could be pushing frequent updates to your applications, for example, every hour, every 3 hours, every 6 hours, every other day, in the form of bug fixes or feature enhancements. infrastructure, it is extremely important to know that infrastructure is used to build applications. It is not the application itself. Now, when it comes to infrastructure, it would help you considerably if you know what you're going to need to build your applications. Half the battle for you to get on the cloud is going to be figuring out what permissions you need in a cloud environment. And by permissions, I mean, as you get in on the cloud, you're going to have a bunch of services that you're going to want to use. And in this case, I'm going to take an example of Google Cloud environment again, Google Cloud Platform. In Google Cloud, you could have your Jupyter notebooks, a place to save your images, containers, a place to deploy those containers, your cloud storage, schema-based databases. Basically, all of those services need to be able to talk to each other for you to be able to build a product. And that happens through permissions. It is highly recommended that you don't figure out permissions one at a time. This is going to cause a ton of frustration, and even progress is going to look like failure. What is recommended is you start with wide open permissions in a sandbox environment, build a few sample use cases, and there has to be a logging mechanism in your cloud environment. Monitor the logs of your cloud environment to narrow down what infrastructure you were using and what permissions were getting used as you were building those use cases. That will help you narrow down the list of permissions you will need to make all those services basically talk with each other. We did it the hard way, where we went one permission at a time. Eventually, it took us way longer to get to a place where we knew what permissions were needed. But at the end, what we figured out was, okay, we're going to need data storage and retrieval. For that, we need cloud storage. In this case, it was Google Cloud Storage buckets. Schema-based databases, in this case, it was BigQuery datasets. On-prem data warehouses that need to be able to talk to the cloud environment. A development environment to run our machine learning experiments in, which was Jupyter notebooks. In Google Cloud Platform, you're going to have Vertex AI that will do this for you. You could have your local instances of VS Code as development environments too for machine learning. And then some sort of a deployment mechanism, which in our case was artifact registry, where we maintain our containers, and some sort of an orchestration platform that allows you to deploy those containers at the end. In our case, again, it's Cloud Run in Google Cloud or Google Kubernetes Engine. So let's talk a little bit about what is Terraform and what it does for you as you get on the cloud. Terraform is basically an open source infrastructure as code tool. You write code to stand up a cloud environment. And this diagram in a nutshell basically explains how this would work, the nuts and the bolts behind it. And this is specific to Google Cloud Platform. Basically, if you work in a large organization, you're going to have some sort of a governance structure. And whether it could be a GitHub repository, for instance. In that governance structure, you're going to work with different teams to build your cloud environment. In Google Cloud, these cloud environments are called projects. These projects are then linked to a Terraform workspace, which allows you to make changes to your cloud infrastructure through service accounts. Service accounts basically say, hey, this is a cloud project that I want to deploy, for instance, a bucket in, or a Vertex notebook in, or so on and so forth. And it allows you to kind of establish communication between your Terraform workspace in the cloud with your cloud project, that is going to be through your cloud provider. In this case, it's Google. Service accounts basically allow you to establish that communication. So what happens is you would create a service account and take the JSON key of that service account, and you would add it to your Terraform workspace in the cloud. You would then set up a GitHub repository where you're going to write all of your Terraform infrastructure as code to stand up different services inside of your cloud environment. In this case, whatever you see in the middle is basically all of that: your Vertex AI, notebooks, artifact registry, Google Cloud Buckets, BigQuery, secret manager, so on and so forth. And all of that infrastructure would then communicate with the Terraform workspace that is linked to your repository. And through your Terraform workspace, will make changes to your cloud environment. So there are two key components that you will need to make this work. First is going to be a service account and the JSON key of that service account that's going to get added to your Terraform workspace. Then you would take you would generate a Terraform token in your Terraform Cloud workspace and add that token to your GitHub repository as a secret for your GitHub repository to be able to communicate with Terraform workspace, to then make changes to your cloud environment. And once you do that, then at the end, what you're going to have is basically a cloud environment, a Google Cloud project in this case, with the different services you need to do your work. As far as the structure of this GitHub repository is concerned, there are multiple ways of doing the same thing, but this is how we approach it. We manage that our cloud environments through GitHub by having a single repository, which has three main branches, if you will. One is for development. One is for stage, where we automate and test things. And the last one is for production, where we have production applications running. And they are managed through a single repository. All of these projects or environments are basically managed through GitHub Action workflows. The process for managing these projects is you open up a feature branch on the branch that you're going to deploy your infrastructure through. You merge your PR through that feature branch. For instance, let's say you're trying to make changes to your dev environment. You would create a feature branch, make changes to your feature branch, open a PR on your dev branch, merge your PR in, which will then trigger a GitHub Actions workflow. That GitHub Action workflow will then communicate with Terraform workspace, which will then update your cloud environment. So let's talk a little bit now about application development and machine learning ops, which is in short known as ML ops. Tools. So programming languages and libraries. At the end of the day, choose what works best for you. We are a Python shop, basically, and these are some of the libraries that we use for our day-to-day operations. For data processing, pandas, sklearn, TensorFlow, or PyTorch for machine learning, Flask to develop lightweight APIs to develop to basically send out the output of our models, Kubeflow to build pipelines that can do this process end to end. And then for our development environments, we basically work either in VS Code or Jupyter Notebooks. Those libraries are just an example of, as you work through your day-to-day operations, there is basically no limit to the kind and the number of libraries you're going to end up using to do different things. So when it comes to ML ops, GitHub is what we use for version control. And I can't emphasize this point enough that good Git habits, such as frequently committing your code and not pushing to the main repo, they go a very long way. And will save you a lot of headache in the long run. When it comes to pipelines, you will have some form of model training pipeline, some form of a model deployment pipeline, and then some form of a model monitoring pipeline. For containerization, you will mostly end up using Docker or some other technology to containerize your code and your models. And then all of this would be automated through GitHub Actions, or that's essentially how we do it at HCA. We automate these builds through GitHub Actions. ML Ops is not traditional application development by any means. And it helps a lot if you know that your ability to quickly deliver applications at the end of the day is going to be driven by how quickly you can experiment with new ideas. As you design your application, as you design your workflows, the components of an MLOps pipeline can be taken and treated as sub-pipelines, if you will, but still be kept a part of the unified whole. Now, this is an example of a model training and deployment pipeline that I'm sharing with you on the right. Basically, on the left is where you source your data from, Google Cloud buckets or BigQuery. If you're using a different cloud environment, it could be a different data source. You pull that data into your experimentation environment, Jupyter Notebooks, for instance, version control your code through GitHub. You create your data sets for model training, and you save your models and version them in some way. In Google Cloud, you can do this through model registry. Both of these components are basically orchestrated through Kubeflow pipelines, where we create a data set, do model training, and then those components of that pipeline are basically separate containers themselves. Artifact registry in Google Cloud is where we would save those containers, those images for these components. And then at the end, once your experimentation is complete and you have a model ready for production, you would then need to containerize your model along with the application code and deploy your container through an orchestration tool. And if you're using Google Cloud, Cloud Run is a managed service where you can deploy your containers, or you could also use Google Kubernetes Engine to deploy these containers. And as you deploy this container, basically you can dish out your predictions in the form of a simple Flask API with different routes doing different things. You could have a route for inference and predictions, a route that triggers model training at a certain cadence, and a route that monitors the performance of your model in real time as new data comes in. All of this stands on top of your infrastructure that you would define through an IAC technology, which in this case is Terraform. So what's what? On the left, you have infrastructure, which is Terraform, creating your cloud environment. And on the right, you have your ML applications, where you have a Python framework that you're using to build your models and your applications. And you need some form of containerization to containerize your models and your code. You deploy that on top of your cloud environment. And all of this is basically managed through GitHub, through GitHub Actions when it comes to your CI/CD processes. What is not recommended is that you build your applications, you containerize them, and then you try to deploy that through your infrastructure as code technologies. So what is not recommended is you build your applications in Python, and then you containerize them, and then you go to your infrastructure as code, and then you deploy it to your cloud environment. We tried to do that, and it was a pain. We learned the hard way, and it was not fun at all. So from experience, what works best is you stand up your cloud environment through your infrastructure as code technologies, and then you build and deploy your applications separate from your infrastructure as code on top of the cloud environment that you will create through IAC. But all of this is version controlled and managed through GitHub for your CI/CD processes. So some key takeaways. If you are new to the cloud, please don't figure out permissions one at a time. It's very painful. Start with a high-level overview, or start with a high-level project, a sandbox project, if you will, and walk backwards. Don't go one permission at a time. Figure out some of the key technologies that you're going to need to do quick ML experiments and product iterations. And honestly, don't let perfection be the enemy of good. Get something in front of your customers quickly and iterate through it. It's just like startups, basically. Produce a lot of applications. Some of your applications are going to work and some will fail. And the key is that you should be willing to fail more often. Amongst all of this, I would say probably one of the biggest takeaways is no single person is going to know all of this. This is going to be a big team effort. So if you work in a big organization, build partnerships with different disparate teams across the organization. Have a big heart and share your success with other teams. You will get more from your data scientists if they write less infrastructure. And they are able to devote more time to orchestrating and building data pipelines, run experiments, build models, and deploy those models through applications. With that, I am going to open this up to questions. I know I threw a bunch at you guys, so I'm happy to take any questions if you have any. But thanks.